So let's look at the derivative of f of x equals 4x arctangent x. Again, this could be written as tangent to the minus 1x as well, using the other notation. F of x equals 4x arctangent of x. So standard problem here, we have something next to something else, so we have to use the product rule. So that would be the first, 4x, times the derivative of arctan of x. Well, we know from the previous video that derivative of arctan of something is just 1 over 1 plus x squared in this case. And then that's going to be plus, by the product rule, arctan of x times the derivative of 4x, which would just be 4. And then let's just do a little bit of cleaning up here. We get 4x over 1 plus x squared plus 4 arctangent x. 4x over 1 plus x squared plus 4 arctangent x. And now we've done the derivative of 4x arctangent x. Let's consider one more. F of x is equal to the inverse sine of 3x squared minus 8. So this time I'm using the inverse notation here. There is no product or quotient rule here. I'm just going to basically have to use the chain rule because I have something inside of my inverse sine function. So I would let u be my inside part, 3x squared minus 8. That would make f be inverse sine of just u. And so when we do the derivative now, we can use our chain rule and the rule for the derivative of inverse sine. So remember, the derivative of inverse sine is just going to be 1 over, a little ahead of myself there, 1 over the square root of 1 minus u squared. Right? And then that's going to be times, by the chain rule, the derivative of u. So, which would be 6x. And then we just want to clean this answer up a little bit, make it look a little bit nicer. So we can write that as 6x over square root of 1 minus the quantity 3x squared minus 8 quantity squared. Now you could do a little bit of simplifying, and if we wanted to do some more with this answer, we probably would do that. But for now, we'll just leave it as it is. Right? We could square this thing and subtract the minus 1 minus all that stuff, and have some expression here inside the square root. But it's just as simple for us to leave it as it is. And so now we've done the derivative of the inverse sine. And problems with inverse secant are similar as well. And you can find a few of these in the notes. But hopefully a couple videos here will help you kind of appreciate and understand how to do derivatives with these inverse trig functions. We're not going to bother with integrals. There are integral rules. But when you get into Calc 2, you will talk about one of the units involves what are called trig substitutions. And that allows you to do integrals. And it's far better to do integrals of your trig functions using those rules than it is to just memorize a bunch of integration formulas, which would be your only option right now. Okay, so at this point, that'll kind of wrap up this video. Again, as always, if you have questions, please ask me, and I can put in some more detail or do some more examples.